Hey everybody, this video is going to cover lesson 3. We're going to talk about necessary vocabulary and some theorems and things that we'll need for this lesson. So this is the beginning page. We're going to do this together as a class. If you would, for me, go to the next page. It should say S12 at the bottom. So we need to talk about what an angle is. I'm going to do a lot of highlighting. If you need to pause the video, rewind it and so you can write down what I said, then do so. An angle is formed by two rays with a common endpoint. An angle is formed by two rays with a common endpoint. So it looks kind of like this. No, that's kind of big. Let's see. Better. So here are two rays. This will be ray OA. The other ray, the bottom ray, is OB. Okay, so an angle is formed by two rays with a common endpoint. For this angle that I drew, it's rays OA. Don't forget your symbol, and OB. Okay. By the way, the symbol for angle when we write about it and name it, looks like this. It's like a flat less than sign. Okay. That's your symbol for angle. So let's talk about naming your angles. There's three ways to do this, okay? The first way is with 3 letters. 3 letters. What you need to remember about this is that the vertex must be in the middle. Put that right here for me. Vertex in the middle. So for this angle up top, I could name it angle AOB, right? My vertex letter is O. By the way, you don't know. This letter right here in the corner is the vertex. Okay. Angle AOB or angle BOA. So the only thing that matters is that the vertex letter goes in the middle. The other way to do it is with the vertex only. Okay, so the vertex letter is O, so we call it angle O. Or we could put a number, right? There, you might see little numbers on the inside. They won't have a degree sign, so you know it's not the angle measure. So we could call this angle 3. And it's just shorthand for us, so we don't have to write all those letters out. Alright, next definition is interior. So this one, the definition that they have here looks a little crazy. I'll just scratch this out. Okay. Basically, here's your angle. Okay. This is the interior. Out here is the exterior. Alright, inside the angle, outside the angle. Pretty self-explanatory. Alright, an angle bisector. Bisect, right, means cut in half. So if C is in the interior of angle AOB, do this in a different color. C is in the interior of angle AOB. So I'm going to put it here, roundabout. This is going to be C. And, I'm going to highlight again, guys, so y'all listen. And, oh well, kidding. The measure of angle AOC So this one right here is equal to the measure of angle BOC, which is this one right here. If these two angles are the same, right, then this ray right here, this ray OC, is an angle bisector. Okay, this is an O. This symbol, again, y'all are going to see me abbreviate a lot. This symbol means angle. It's an angle bisector. So, we already know that the measure of angle AOC and BOC are the same. We could say that the big one, the measure of angle AOB, is equal to 2 times the measure of angle AOC. All right, now take a minute, go back up to your picture, see if you agree with that statement. Angle AOB, that angle is worth 2 of angle AOC, or 2 of the other angle, BOC, or COB. Okay? Or you could write it in a different way. You could say half of the big one, AOB, is equal to angle AOC. Ooh, running out of space. Measure of angle AOC. And you could also put in here measure of angle BOC. Okay? Alright, so if you have questions about the angle bisector, and the equations that I wrote, you just need to ask. Alright, so moving on. So, and we told you right here, right, this right here means measure of angle whatever equals measure of angle whatever. So the actual angle measures, the actual degree measures are equal. Okay, so let's talk about some things that we assume. Number 2 is important right here. Ooh. Number 2 is important. If C is a point in the interior of angle AOB, then you can add the 2 small angles to get the big one. So here is my angle. I'll draw these pictures. A, O, this is B. C is somewhere in the middle. It's somewhere on the interior. Doesn't have to be a bisector, right? It just has to be somewhere on the inside. Do y'all see that we created now 2 angles? There's one angle here, and then there's a second angle over here. Together, those 2 angles make up the big one right here, right? That's all that says. You can add up the angle measures of the first angle and the second angle, and you'll end up with the measure of the angle for the whole figure. Okay? All right, more vocab. A linear pair. These are important. A linear pair, if 2 angles form a linear pair, then they are supplementary. And we saw last time that supplementary meant that they add to 180. Okay? So to be a linear pair, they're going to form a line, right? They're going to be adjacent to one another on the line. So angle BAC and angle CAD, right? here is BAC, and here is CAD. Do y'all see them in here? These angles right here. This is one, and this is the other, right? Those two angles add to 180. How do I know that? Well, they form a line, okay? Angles that are adjacent and on the line together, adjacent and add to 180, form a linear pair. All right, so last bit for lesson 3, this vocab, midpoint. Midpoint is just like angle bisector, except it's a point, not a ray. So here is A and C. B for this figure is the midpoint. I'm going to mark that this segment and this segment are congruent, okay? So just like the equations we had for the angle bisector, you can do those same equations here. So AC, the whole segment, right? AC is equal to 2 of one of the small ones, 2 of AB, or 2 of BC. Okay, it takes 2 of these little things, takes 2 of these to make the whole segment. Or you could do the halves as well, right? You could say that half of AC equals AB. Or you could say half of AC equals BC. All right. One more thing. A zero angle is just a ray. Doesn't open at all. It's just a ray. A straight angle is a line. And the line, remember again, measures 180.